Let's start. So, for year 11s, this is chapter 9, linear algebra. For year 12s, this is chapter 4, so hence 4.3. To do 4.3, you are learning to solve equations. Now, there are two types of equations you're going to be dealing with in this exercise. You're dealing with what we call one-step and two-step equations. One-step most students can do looking at the equation. So here's an example. This is called a one-stepper. Something plus 5 equals 20. X is a number we just don't know. But logically, you can probably do this without using BODMAS or the inverse of BODMAS. What number would X have to be if I add 5 to it to get you 20? Let's go with Michael. 15. So we can all look at that and say 15 must be the answer. Now, I know that's great. It's intuitive. But what I want instead is an actual method. Here's the method. The method is you're going backwards from BODMAS, which is SAMDOB. If you've heard of it, great. If you haven't, it's okay. I'm going to teach you how to work with it. SAMDOB is meant to give you a direction of what you should remove first. Okay, so this is only for solving, meaning you're going to do the inverse operations of the things you see. So here, instead of BODMAS, where you look for brackets first, and then powers, division, multiplication, addition, subtraction, you're now going to look for subtraction or addition first to get rid of. Then your next step is any multiplication or division. That's your second. Last thing you get rid of, brackets or powers. That's the last thing you should do. Okay? Here's an example where you would use SAMDOB for a two-step equation. Thanks, boys. Actively listening or actively taking notes. You see, with this problem here, unlike before, it was easy to say that the answer for X is 15. But when you have 3X plus 5 equals 20, and I ask you, what would X have to be? Some of us may know it, and some of us may not intuitively know what X is. You need to triple it, then you add 5, and you get 20. It's not a whole number that's going to be easy to figure out. So because of that, well, actually, it is a whole number that you can figure out. But to solve this more methodically, we are going to go through SAMDOB. Now, to go through SAMDOB, first thing is you have to identify the operations. 3 next to an X. What does 3 next to an X mean again? Can I please have? Let's go with Billy. When you have a 3 next to an X, what's happening between the two? Multiplying. So this is actually going X times a 3, whilst this one is adding a 5. Now, according to SAMDOB, I want to look for subtraction addition first. So in this case, I'm not getting rid of the times 3 first. I'm going to get rid of the plus 5. Now, what's the opposite of adding 5? Let's go with Finita. What's the opposite of adding 5? Subtracting 5. These are called inverse operations. So here, I minus 5 on the left of the equation. Whatever you do to one side, you must do to the other. So then you minus 5 on the right as well. Now let's work this out. 5 take away 5, or positive 5 take away 5, they're opposites of one another, so they should cancel out. In this case, it cancels out to be 0. That means on the left side of the equation, I should still have 3x, because I haven't done anything to it. Whereas on the right-hand side, 20 take away 5 gives me 15. This simplifies the problem a lot more. So I'm removing any subtraction addition first before any multiplication division. Now there's the times 3. 3x is the times 3. That's your multiplication. So the opposite of multiplication, Josh? What's the opposite of multiplication here? Opposite of takeaway is add. Opposite of times would have to be division. Good. So instead of times 3, I would divide 3. Very good. So in this case, to get rid of the times 3 here, I have to then divide 3 on the left. But if I divide 3 on the left, then I must do the same on the right. Here we go. Let's see what that gives us. 15 divide 3 on the right. What does that give us? Let's go with Archie. 15 divide 3. 5. Good. So we got 5. And then over here, 3 divided by 3. What is that, Liam?
3 divided by 3 is 1.
1. Beautiful. So that's why that cancels out to be 1. And we have 1x. This is called a two-step equation that you need to practice. It is expected at a foundation level in the exam. There aren't too many questions on it, but there will be a few. So that's why in terms of the exercise, I don't focus too much on it, but I do expect you to at least understand the method to get there. Okay, so it's still required. Foundation level, you still need to be able to solve one-step and two-step equations. Okay, so in this case, the answer is 5, so it is true. If you triple 5, you get 15. 15 plus 5 gives you 20, so it does make sense. All right, but how did I get through that? I used SAMDUB to guide me. SAMDUB's doing the opposites of each operation you see. So the opposite of plus is minus, opposite of minus is plus, opposite of times is divide, opposite of divide is times. Okay, now it's not as easy as I understand. It's just practice, and that's what the exercise is to get you to do. Yeah? Let's do another example. So I'm going to do example 1. I'm going to show you how you can do this a bit quicker using SAMDUB. Yeah? So here we go. By the way, I expect everyone to be copying notes during this time. So if you're on your laptops, you're not copying notes. So laptops away, thank you. Laptops away, you should be copying notes. Here we go. Next one. You got 6 bracket a minus 3 equals 72. Your first job is to identify the operations. Let's go with Connor. 6 next to a bracket. What's in between it? Between the 6 and the bracket? It would be times. And that's sometimes students don't realize that. But next to each other, if it's a letter and a number, it's times. If it's a number with a bracket, it's times as well. So another way of thinking about it is this is actually multiplying by 6. Inside the brackets, we clearly have a subtraction of 3. Okay? But keep in mind that's brackets. So let's go through SAMDUB again. SAMDUB. You look for subtraction addition first. You look for multiplication division second. And then you look for brackets third. Now, remember brackets is going to be last. So you don't deal with this a minus 3 first. Do I have addition subtraction? I do. Boys, thanks. I do have addition or subtraction. What's the problem? It's in the brackets. So actually that's meant to go last. Had there not been brackets, you would have got rid of that first. So the trick here is get rid of multiplication division, which is the times 6 first. That's what's a bit tricky for a lot of students at the start. Yeah? So here, because this is brackets, that's meant to be the last group I'm doing, then I need to get rid of that 6 first. So now once you identify the operations, we can follow. Get rid of this times 6. The opposite of times 6 is what, Olivia? Opposite of times 6. Divide. What am I dividing by? Dividing by 6. Very good. So here's my equation. 6 bracket a minus 3 equals to 72. To get rid of that 6, we are going to divide by 6. Whatever I do to the left, I do to the right. So here we go. 6 divided by 6 cancels out. And then you're left with just the brackets left, which is a minus 3. And you can see here, a minus 3. Now you only have the subtraction to worry about. That's the last thing you need to do. The opposite of minus 3, let's go with Jasper. Opposite of minus 3 is plus 3. So whatever you do, can you see how I'm always writing the opposite signs? Whatever you do to one side, you do to the other. So here I say plus 3, add 3. Now remember, you can use a calculator. If you're unsure how to add the fractions, you've got a calculator. Pav.
Is it 7 or 72?
Oh, sorry, it's 72. Thank you. Thanks for that pickup. 72 on 6. So it's not a fraction, actually. It ends up being a nice number. Negative 3 plus 3 cancels out. And you're left with a is equal to... Again, if you're unsure with the division, you can use a calculator. 72 divided by 6. What is that? 72 divided by 6? 12. Very good. So this is actually 12 plus the 3. A equals 15. Remember, you can use a calculator for all this part. But the calculation as you're doing it, that's the expectation. Copy those notes, please. Make sure you have those notes down. I'll do one more example, and then for those who feel confident with this type of technique, the last example is a worded problem. I want you to have a go with that. But otherwise, I'll be then just checking on your basic fluency skills for linear equations. Okay, so here we go. Flip over the page. Flip over. All right, flip over the page. Now, this is your second type of skill. So you had one-step equations, two-step equations. Thanks. Two-step equations. Your last one is when you have unknowns on both sides. This type of skill, thanks Josh. This type of skill is going to be probably for the 12s more important. For the 11s, I am putting something similar to this on the exam. You guys need to learn how to solve two linear equations together. For the 12s, you guys are learning simultaneous equations, and that's one of your starting points to it. So to me in the exam, that is a typical one you'd get. You're probably less likely to get this type, but you were more likely to get this type. But in order to solve this problem, you need to build these skills from here. That's why. Okay, so let's have a look at this problem here. How do we solve it when we have x's on both sides? Here's my tip. Always remove the smaller x. Because if you have two x's on both sides, get rid of one of the x's on one of the sides. Okay, right now I've got an x on this side and I've got an x on that side. So the question is, which one's smaller? Is it positive 2x or is it positive 5x? Which one is smaller? Positive 2x. So this positive 2x, what's the opposite of plussing 2x? You need to then do the opposite of that. The opposite of plussing is minusing. So we know it's minus 2x on the left. Why did I minus 2x? Because I'm trying to remove the small x. Minus 2x on the left, then I must also minus 2x on the right. 2x take away 2x, we know it's going to be 0 because it's you got two apples and you take away two apples, well, you have no apples, right? Here we go. We now have 4 on the left-hand side because these have cancelled out. 5x take away 2x. How many x's would I have left? Let's go with Amelia. 5x take away 2x simplifies to 3x. Very good. So I've got 3x minus 8, and you're back to the problem of two-step equations again. Okay, so same idea. 3 next to an x. Jack, what does that mean? So we've got times 3 here, and this one is a minus 8. So using SAMDOB. Here we go, SAMDOB again. You got subtraction, addition, multiplication, division, then brackets. That's right, because you're inversing it. Because you're inversing, you do the other direction. And that's why it's a bit confusing for some students. All right, here's SAMDOB. Which one do I get rid of first? Can I please have, let's go with Kate. Which one of these two should I get rid of first according to SAMDOB? Is it times 3 or minus 8? Minus 8, beautiful. Boys. Thanks. If you're wondering why I'm a bit more clear-cut on when you're talking, it's because these skills are a bit harder than percentages. So I'm trying to make sure that you copy those notes. Yeah? All right, so Katie's correct. Minus 8, that's subtraction, addition. Opposite of minus is add. So instead of minusing 8, we add 8. So here's my equation. 4 equals 3x minus 8. Get rid of the minus 8 by adding 8 on one side. Therefore, you add 8 on the left. Here we go. 4 plus 8 gives me 12. 3x is left over because negative 8 plus 8 cancels out. What's the next step? I already got rid of the minus 8. I need to get rid of this times 3 now. What is the opposite of times 3? Can I please have Estella? Opposite of times 3. Divide 3. So this is the last thing I'm going to go with from my SAMDOB. Times 3 here. Then I do divide 3 on both sides. Okay, so the order matters, and the way to remember is SAMDOB. Get rid of subtraction, addition first before any multiplication, division, and before any brackets. So here we go. Let's work it out. 3 divided 3, we know it's 1. So you get 1x is equal to 12 divided by 3. Gives you 4. I want to zoom out so you can see the calculation. Please copy these notes down because those two examples are the beginnings of linear equations. Chapter 4 for year 12. Year 11, it's chapter 9. If you don't build your two-step equation skills, then doing this type of equation in the exams will be harder. So you just need to know how to solve two linear equations together. That's one of the first steps. Okay? Now, for those who are really strong, then don't look at my guided solutions. Try the worded problem, but I don't expect everyone to do this one. Okay? This is only once you've built these skills. So if your fluency skills are strong, then the worded problems will make sense. I've guided you to try to get you towards the answer. I'll fill it in later, and then I'll show you the solutions at the end. Okay? All right. It's currently 2:24, so I should have about 40 minutes. My goal today is to go through the Year 12's homework for Chapter 3 percentages. There's only a few of you I need to double check for Year 11, so when I call you up, if you don't have your book, I'll test your skills. Cool? Work on Chapter 3 for most of the Year 12s, and for Year 11s, I think you guys are finishing off Chapter 8. If you're up to date, you should be on Chapter 9 at the moment. Okay? All right, Tim, I'm going to stop the video.